Okay, what I'd like to do is just a quick video on extension, the extension solving absolute value equations with two absolute value expressions. And this is lesson 6. So again, this is beyond the scope of this course. I think I mentioned that in class, but if students are interested in doing this in the regular level, absolutely they can do that. What I want to do is I do want to use a graph to help me. With graphically, we would just plug this into our graphing calculator, but what I want to do is I want to use a little graph to help me to visualize what we're doing here. So I want to just think about, what does y equals 2x minus 3 look like? Well, that would be a equation. If I had 2x minus 3, I would start down here at negative 3, and I would just graph with that slope of 2. We would graph, a positive sloping line. Slope of 2 would look sort of like that. Okay, in fact, I'm just going to do this. I'm going to break that up into two kind of parts here. So this would be, right there would be our line y equals 2x plus 3. And then, of course, when we want to take the absolute value of that, this negative portion down here would reflect up, and our graph would look something like this. Okay, and this would, of course, become a plus 3 there. And so this would be what the graph of y equals the absolute value of 2x minus 3 looks like. And I'm just going to erase this bottom part now. We know that this here is our x-intercept, which would be at, okay, if this is 2x minus 3 was equal to 0, x would be 3 over 2. And that's what they've got over here. Okay, so this is 3 over 2 or 1.5, okay? Or let's just leave it as 3 over 2 because I guess that's what they've got in the notes, okay? And then if we were to graph the x plus 4, okay, x plus 4, it would look something like this, okay? This would be our 4, of course, and our graph has a slope of 1. It would look something like this. And of course, this would continue on. Okay, but if we wanted to graph the absolute value of that, we would have, of course, y equals the absolute value of x plus 4, and this would, again, this portion would reflect up, and this value right here would be negative 4, right? If x plus 4 is equal to 0, then x would be equal to negative 4. So what I want to do is, again, erase that little bottom part. Now what I want to do is we want to look at, before we start solving this, what cases do we look at? We've had a case 1, case 2. Now we've got a bunch of cases because we've got 2 different absolute value functions. So what I want to do is I want to break this up into sort of intervals. And that's what they're doing on this number line here. But I think it's really a good visual if I break this up with the graphs themselves. So I'm going to look at that portion. Oops, and this portion, that's really crooked. This portion, and the third portion. So what I want to do is if I look at the portion over here, okay, to the left here, what I want to do, and let's maybe just extend this orange graph a little bit more, okay? I can see that this was the positive of this graph. The reflection, this was the negative case, wasn't it? Right? Because f of x, the graph was negative down here, down below the x-axis, so the reflection is now the negative of the negative. Okay? And same thing with the green. This was the positive, and this is the negative. So if I look in this portion here, if I look sort of right here, okay? If I look, maybe let's just, right, if I look at this portion of the graph, and I don't really need to leave a big blob there, but if I look in this portion, I can see that both of my graphs are negative. I've got 2 negatives, right? They're both negative, negative, and negative. And that's basically what we're saying over here. They're saying this is in this subdomain where x is less than negative 4, the 2x minus 3 is the negative, and the x plus 4 is the negative. So when we solve that, okay, we've got the negative of 2x minus 3, which when they distribute it is negative 2x plus 3, and the negative of x plus 4. Oh, the negative, sorry. It's minus the negative of x plus 4. I mean, really, we could put those like that. We could put minus the negative x plus 4, which is going to be a plus x plus 4, okay, which we end up getting down below here. So we've got negative 2x plus 3 equals 8, negative x is 7, x is negative 1. Now it says, is the solution in the subdomain? So is negative 1 out here in this subdomain? No, it is not. So therefore, this is an extraneous root. It is not a solution, okay? Not part of the solution. Now I want to look at this sort of middle section of these two graphs. In this middle section, the green portion is positive, okay? I could just color code this, I guess. The green portion is the positive, right? We can see that that's the positive green. And we've got the negative orange in there, right? The negative orange. This is the negative orange, and this is the positive green. So the orange being the 2x minus 3 is negative, so that one is negative. So we would end up with a negative 2x plus 3 here, okay? And the green is positive, okay? So we get our x plus 4. We just have to be cautious when we go down below here because we still have to distribute that negative sign. So that can always be tricky. So we end up with a negative 2x plus 3 minus x plus 4 equals 8. So the negative 2x, right, it's a minus the positive x plus 4. So 2x plus 3 minus x minus 4 equals 8 when we distribute that negative sign. So we've got our negative 3x minus 1 equals 8. So negative 3x is 9, and x is negative 3. And now what we want to do is just do a double check that that negative 3 falls within this domain, and it does. Okay, that's what sort of this number line up here is for. Okay, so it looks like x equals negative 3 is one of our solutions. And then for the last portion of this graph, what I want to look at is this right-hand portion. And I can see I've got the positive green and the positive orange. So those are both positive. So the positive orange here, we've got our 2x minus 3. It's the positive of that. And the green here, we've got the negative of x plus 4, which would be negative x minus 4. So again, when we solve here, I'm going to solve 2x minus 3, and that will be our positive, minus the x plus 4, which is going to be the negative, and that's equal to 8. So we get our 2x minus 3 minus x minus 4 equals 8. So x minus 7 equals 8, so x is equal to 15. And if we look and do a little check, 15 is over there greater than 3 over 2. So these should be our two answers. Our final solution is negative 3 and 15. Okay, and if we were to do a little check there, those would both check out. Okay? All right. So if you want to pause the video and maybe try the next one, if you're interested, or we can just do it together, okay? It's up to you. If you want to pause and try. All right, if you don't feel comfortable trying it on your own, what we'll do is I will guide you through the whole entire thing. So again, what I would do for this equation is I would look at each of these graphs separately. So I would look at the 2x plus 1, okay, the absolute value of that, and I would look at the y equals absolute value of x minus 2. So when we think of that as a number line, okay, if we were just considering the number line, then we would have x equals 2 and x is equal to negative 1/2. And I think we're probably comfortable with finding those values, right? Solving for x, 2, positive 2, and negative 1 divided by 2. So if I were just to kind of do a little baby sketch again, because I think that that visual is quite helpful, okay? And so if we were just to do sort of a little sketch of y equals 2x plus 1, I would start with that 1 there, slope of 2 over 1, and of course that graph would be, you know, kind of a little bit steeper on the steeper side. It's going to go like that, and then it would travel down here. Whoops. right? It would travel down like this. But then, of course, once we reflect it, it's going to come up like that. So that's the negative portion. This is the positive. And this x-intercept is negative 1/2. Okay? And then the 2, x minus 2 would have looked like this, with a slope of 1. Okay, and then of course, right, this would continue down. But now, of course, this would reflect up. And so there's our positive, and here's our negative. Okay, so let's erase all these bottom parts here. Oops, strategically sort of put together in parts so I could erase those. So now, oh, and this one here, this is the 2. So between here, we've got these 3 sort of, right, we've got this section, right, we've got this section, we've got this section. So when x is less than negative 1/2, we've got a negative, and we've got a negative. Okay, they're both negative. Between negative 1/2 and 2, the green, which is the, let's just label that really quickly, the green, which was the y, is the absolute value of 2x plus 1, and the orange, which was the absolute value of x minus 2. Okay, the orange is the negative, and the green is the positive. And then beyond the 2, okay, hopefully we can see these, right? We've got this little section, and then this section, and then this section, and this green would continue on in the positive, right? So here we've got a positive and a positive. So we want to look at these domains separately. From x is less than negative 1/2, we know that both of these would be negative, so we've got a negative case. The negative 2x minus 1 minus negative x plus 2 would equal to 2. So negative 2x minus 1 plus x minus 2 is equal to 2. So that's going to be a plus 3 though. So negative x is equal to 5, so x is equal to negative 5. We would just want to double check, is negative 5 less than negative 1/2? Yes, it is. So this does appear to be a solution. Okay, when we look between negative 1/2 and 2, okay, and I'm going to include the equal sign in this portion, okay, it has to go somewhere, so we're going to put it with the middle. We've got the negative orange, which was the y minus 2, okay, so we've got the positive 2x plus 1 and the negative x minus 2 is equal to 2. So we get 2x plus 1 minus negative x plus 2 and 2x plus 1 plus x minus 2 is equal to 2. So we end up here with the 3x equals 3, right? 1 minus 2 is negative 1, plus 1 is 3, so x is equal to 1. Okay, and if we do a little double check here, yes, 1 is between negative 1/2 and 2. So it looks like that one is also, right? Is 1 between negative 1/2 and 2? Yes, it is. Okay, and then our last solution here, we've got our plus plus, where x is greater than 2. We've got our absolute value of 2x plus 1 minus the absolute value of x minus 2 equals 2. So we've got our plus and our plus. So 2x plus 1 minus x minus 2 equals 2. We still have to distribute this initial minus sign, 2x plus 1 minus x plus 2. oops, equals 2. Okay. Those guys will cancel. And I believe we get here 2x, 2x minus x. 1x equals -1. Okay, x equals -1. And if we look at the domain, -1 is definitely not greater than 2. Okay, -1, is -1 greater than 2? No. Okay, -1 is not greater than 2, so therefore this is not a solution. That's extraneous. So here are our answers. X equals -5 and x equals 1. Okay, if you wanted to do the assignment questions on those ones, I would just go right ahead. Okay, good luck, and please do not hesitate to contact me if you have any questions or concerns. Thank you.